Good evening, everyone. Hello.
Good evening, sir.
Good evening, sir.
Good evening. All right. So I've sent some problems in the group. Would you please check? Have you received?
Yes, sir.
Okay, let's solve those problems now. I want you all to try along with me. Students, have you tried the first one? I'm just waiting for you all to try. Look at the very first one. He says, what is the reading of the scale? That means he's asking the tension in the string. I told you, reading of the weighing scale is normal reaction. Reading of the spring balance is tension in the string.
Sir, can you repeat again?
Yeah, reading of the weighing scale, weighing machine is normal reaction. But reading of the spring balance is tension in the string. So he's asking you to measure the tension in the string. That's it. He's saying reading of the scale, right? So he's asking you to measure tension. So what's the tension in the string? Just draw the FBD, you'll get the answer. Okay. Ten kg. So I'll choose ground as reference frame. There is only one reference frame here, inertial reference frame. If at all there is non-inertial, we'll go for non-inertial as well. But there is only one reference frame, which is inertial. So with respect to that frame, I'll draw the FBD, 10 kg block, tension in the string, 10g downwards. No acceleration. So acceleration diagram, MAD is very simple. Mass is 10 kg, acceleration is 0. So FBD is complete. FBD and MAD both are complete. Acceleration is 0. So I'll write T minus 10g equal to 0. So T equal to 10g. That's the tension in the string, or 100 Newton. Let's say G is 10 Newton, 10 meters per second square. So I'll have tension as 100 Newton. That's the answer. Now look at the next question. The wall has been replaced with a second 10 kg block. What is the reading on the scale now? Again, all you have to measure is the tension in the string. tension is again 10 kg. Mass is 10 kg, tension is again 10 G. All right, so there's no change in tension in the string. But look at the third case. Now, one mass is 20 kg, the other mass is 10 kg. Now the scale is same as before. You have to find the reading of the scale. So again, find the tension in the string. How do you find the tension in the string in the third case? I'll find the acceleration first. Acceleration is, look and say, what is the acceleration of the blocks? Ten kg, 20 kg. What is the acceleration of the blocks? Each block, this comes down with A naught, this goes up with A naught. So what is A naught here? How do you get A naught? Supporting force minus opposing force by total mass. Tell me what is the acceleration of the block? Vignesh, Gayatri, Bhaskar, and Sophian. Seems like there is network issue at your place.
So is
Sorry? Vignesh, what's your answer?
Good evening, sir.
Yeah, good evening, Namneet. Vignesh, what is A? What is 2A? How do you get 2A? There's no additional pulley here. There's just simple constant equation is this moves by x, that comes on by x. So if this is A, this is A. What is 2A? No, I want you all to get this right. Gayatri, Shane and Newton, all right.
so is
So
it G
Bhaskar,
by 3?
yes, G by 3 is the acceleration, right? That's right. I'm asking the acceleration. Bhaskar, I'm asking the acceleration, not the tension. Tension we'll find out, but I'm asking the acceleration of the particle. Yes, Vignesh, it's G by 3. So whenever I ask for acceleration, let me know in terms of G. All right, not acceleration A. A is
Okay.
unknown. Remember this. All right. This mistake you're all committing every time. Whenever I ask you acceleration, you're telling me 2A and A. That's a constant relation. A and A is a constant relation. If this goes up by X, that comes down by X. If this goes up with V naught, that comes down with V naught. But, and if this goes up by A naught, that comes down by A naught. But what is A naught? A naught is 20G.
20
Yeah, Navneet.
A naught is 20 G, sir.
20G minus 10G by 30 is A naught. So that is nothing but 10G by 30, which is nothing but G by 3. So A0 is G by 3, not 20G. Bhaskar, is it okay?
Yes, sir.
Okay, now once I get the acceleration, I need the tension in the string. So I'll select one of the blocks. I'll select this block where I'll write FBD of the block is T 10G, acceleration is G by 3. So I'll write T minus 10G is equal to 10 times 10G by 3. I mean 10 times G by 3, mass into acceleration. So T is equal to 40 G by 3, which is nothing but 400 by 3 is my tension in the string, not 300. I'm going step by step and asking you something in the, while doing a certain step, answer that one. Do not jump to the answer. Do not jump to the conclusions. Did you all understand how I have written this equation? See, this is a very simple problem, students. I've done this before in the class. And these problems, all problems which I'm doing now, I've done it in class. All right. So if at all you were to do revision, 10-minute exercise, these questions would be easy now. But presuming, I mean, seems like you have not done. That's why I'm doing it again. All right. It's actually a waste of time. We are wasting time. By repeating from problems, we are wasting time. I can go for new problems, but I'm still doing the same old problems. All right, this FBD is understood, MAD is understood. Then I've written F is equal to M into A. T minus 10G is equal to mass into acceleration. Why did I write T minus mg, 10G, not 10G minus T? Because my acceleration is in the direction of T. So my supporting force is T, opposing force is 10G. 10T minus 10G is equal to 10 into G by 3. 10G goes to the right. I'll get T is equal to 40G by 3, which is 400 by 3. Do you all get this acceleration?
Yes, sir.
Gayatri, Navneet, Bhaskar.
Yes, sir.
Okay.
Yes, sir.
Okay, let's look at the next pick. Fourth question. A smooth block of mass m is connected with a string of stiffness constant. Stiffness k is equal to 20 Newton per meter, and natural length is 0.25 meters. If the block is pulled to the new such that new length of the spring becomes L is equal to 0.3 meters, find the acceleration of the block at the moment when that is released from the given position. So natural length is 0.25. New length is 0.3. So extension the spring ఎంత ఉంటుంది? What is the extension in the spring? Students, what is the extension in the spring?
0.05, sir.
Okay. Navneet, what is the extension in the spring?
Zero point
0 point? Zero point? How much, Navneet? Bhaskar? Get hold of the problems whichever we're doing now. Please get hold of the problems now itself, students. We'll slowly increase the level of the problem today itself, but you people are still not letting me go ahead. Please try to understand. I've got a string of natural length L0 is equal to 0.25 meters. It's extended to a length of 0.3 meters. So the extension is delta xs or xs 0.05. And string constant is 20 Newton per meter. So what is the force on the block now? Is it pulling or pushing? Does the block get pulled or pushed further?
pushing.
No. Is the spring pulling the block or is the spring pushing the block?
Pulling, sir.
Pushing the
Pulling is correct.
Sir,
Yes.
it pulls, sir.
Pulling, sir.
Yeah, that's right. That's right. Pulling because it's extension. See, graph ఇలా ఉంటుంది. My particle is extended here. So force is negative, which is pulling. If the block is compressed, string is compressed, block is pushed towards left, string is compressed, then it will start pushing it. At equilibrium, no force. All right. Now what is the push? F is equal to minus k naught into x. So that is minus in magnitude. If I just find out mod f is k naught x, which is 20 times x, which is 0.05, which is how much
1.
is this? Yeah, 1 Newton. So I can write this as minus 1 I cap. If I take x-axis on the horizontal x-axis, is horizontal line is x-axis. So my force would be minus 1 I cap in newtons. Magnitude is 1 Newton. It is directed towards left, which is negative I cap. All right. Now force is done. Now what if my length would be 0.25? Sorry, 0.20. How would the force be? If the length from 0.3 to 0.2, 0.02, 0.20, how would the force change? What is the compression? Is the spring compressed or elongated?
Elongated, sir.
No. If I make the
Okay.
distance length 0.20.
0.35. So it's look like 0.30.
Okay. It's 0.30 is the one first case.
Yeah, sir.
It's 0.2. It's 0.20.
0.20.
Okay, sir. It's
So is it
compressed,
compressed
sir.
or elongated?
Compressed, sir.
Yes, compressed, right? Now that means it will push the block towards right. So what is the force going to be now? Force is going to be 1 Newton again, but I cap. F2 would be
Positive.
1 I cap in newtons. Because compression is 0.05 again. So force is going to be same in magnitude, but opposite in direction. All right. If at all I were to leave this block here, this would overshoot the equilibrium position and reach this position 0.2 and stop here again, oscillate between 0.0, 0.2 and 0.3. It will oscillate about the origin from 0.2 to 0.3. You all agree with that?
Yes, sir.
Okay, look at the next one. Next pick. Eighth question. Two blocks are connected by a string of natural length 2 meters. Force constant of the string is 200 Newton per meter. Find the spring force in the following situations. A is kept at rest, B is displaced by 1 meter in the right direction, towards right. Right. So spring is elongated. And how much is the elongation? What is the extension in the spring?
1 meter, sir.
Yes. So force would be K into elongation. Extension in the spring. So I've got block A. Natural length is 2. This block is shifted towards right by 1 meter.
1 meter.
Right. So this block will get pulled with a force of K times the extension. K is 200. Extension is 1 meter, which is 200 Newton. In vector form, 200 minus 200 I cap. If at all I take x-axis in along this direction, horizontal direction, I cap is towards right, minus I cap is towards left. So my force is minus 200 I cap in newtons. Similarly, tell me the answer for B. Is
200
the
I
block
cap,
B
sir.
for the B also?
Yeah, sir.
200 I cap or 200 minus I cap?
Sir, 200 I cap, sir.
Okay, why is it I cap, not minus I cap?
Because it's going in left. Left side and it's coming in positive direction, sir. On x-axis.
Okay, so block A is pushed towards left, right?
Yeah, sir.
So that means spring is elongated. Spring is extended, not compressed. So spring will pull the block towards itself. So block A will be pulled towards right, which is I cap. So that's why 200 I cap. That's right.
200 I cup.
How about C?
$400 I cup, sir.
C also.
Yes, sir.
A is displaced by 0.75 in the right direction, B is 0.25 in the left direction. Yes. So what is the extension in the spring?
0.5 meters.
Read carefully, read carefully, Vignesh. He says A is towards, sorry. Okay, A is right. A is towards right and B is towards left. Right. So what is it
0.
spring compressed or elongated?
0.2.
Is the spring
Compressed, sir.
compressed? Compressed, right. So what is the compression in the spring?
Sir, 1 meter?
Yes.
1 meter, sir.
Yes, it's 1 meter. This is 0.75 towards right, 0.25 towards left. So net compression is 0.75 plus 0.25, which is 1 meter. The force is again F into delta X. What's the compression in the spring? But the force will be on A towards left, on B towards right. So on A, 200 Newton towards left, on B, 200 Newton towards right. So 200 I cap minus 100 I cap.
Sir,
Yes.
If you don't mind, can you tell me the answer it is 200 I cap is negative or positive?
I cap is towards right. All right. If I take the x-axis like this, so I cap I've taken towards right, and I minus I cap is towards left. So on A, force is towards left because spring is compressed.
No, sir, I'm not asking that. I
Hmm.
mean for the third case,
Mhm.
is it negative or positive answer?
Yeah, on A it is negative, on B is positive.
So do we need to be separate? Make this answers in separate way for
Yeah,
A and B.
see, yeah, it's A and B separate. Spring
Okay,
force in
sir.
magnitude is same, 200 and 200, but on A it is towards left, on B towards right.
Okay, sir.
Okay. So what if I extend this A towards left by 0.75 and B towards right by 0.25, then what is the magnitude of this force in the spring? What is the tension in the spring?
How
A
many
is
meter?
pushed towards, sorry?
1 meter, sir.
Extension is 1 meter. So what is the force in the tension in the spring now? K times the extension,
200.
200. 200 on A towards right, on B towards left, because it will be pulling. It will pull A towards right, it will pull B towards left, because the spring is extended now.
If is equals to 200 cap, I cap.
Yes, on what? On A or B?
A, sir, A.
And on B?
Minus 200 I cap.
Minus
Yes,
200 I cap.
yes,
Hmm.
that's it. That's it. Good.
Okay.
Now let's look at the next one. Next pick. If you remember, we have done this in class. That's 225 kg or 2.5 kg? 2.5 kg.
2.5.
Okay. And spring constant is, no, all I have to find out is not the compression or extension, but this reading in the string, tension in the string. So tell me one thing. If M is in equilibrium, it behaves as a fixed wedge, right? As if it doesn't move at all. Static
Yes,
equilibrium.
sir.
Or a static equilibrium. It's at rest and it will remain at rest. But if if this behaves like fixed, what happens to 2.5? What happens to 2.5? It
Sir,
slides
they
down.
have, sir, they have given theta also.
Okay, theta is 37 degrees.
Yes, sir.
Okay, okay, thank you. So what happens to 2.5 kg? It slides down, right?
Yes, sir.
With what acceleration will it slide down? Let's find out. See, whenever I ask you acceleration, think of the FBD. If this is 2.5, this is
G.
mg, this is mg sine theta. So that would be mg sine 37. What is sine 37? 3, 4, and 5. This is 37 degrees. Sine 37 is 3 by 5. mg into 3 by 5. So my net force along this is mg into 3 by 5 is equal to mass into acceleration. M gets cancelled out. A is equal to g into 3 by 5. So 3g by 5 is my acceleration, or g sine theta. So this mass slides down with an acceleration of g sine theta. All right.
Yes, sir.
If at all I give you this length of the incline, and I ask you how much time does it take to reach the ground, you can do this, right? Ut plus half it square. L is equal to half g sine theta t square. I'll get t from there. If at all I ask you what is the velocity at the when it reaches ground, that also you can find out. V square minus u square is 2as.
Yes, sir.
All right. So all those things are fine. But now he's asking the tension in the spring. But before that, we need to think whether the spring is compressed or elongated. For that, I need to draw the FBD of capital M. So this is small m. Normal reaction is like this on small m. mg is downward. If I take mg component, I'll have mg into 3 by 5 here, or 3mg by 5, and 4mg by 5. mg sine theta, mg cos theta. Now on this block, on this bed, sorry, normal reaction is like this. Capital mg is downward. Spring forces, is it towards right or towards left? Is the spring force, is it towards right or left?
So left.
Why is it towards left? That means, is the spring compressed or elongated?
Compressed.
Huh?
Compressed, sir.
If it is compressed, my force should be towards right, Gada. See, if I compress a spring, spring will push it towards right.
Yeah, sir.
So spring is compressed or elongated?
Elongated, sir.
Elongated.
Okay, if it is elongated, my force will be towards left. Normal component, I've got two components for the normal. Normal vertical, normal horizontal. NV and H. Is the horizontal component counterbalanced by spring? Spring force? No. Normal reaction is towards left. Component of the normal reaction. Horizontal component is towards left. Spring force is also towards left. If you say it's extended. That means for this to be counterbalanced, my spring force has to be towards right. Fs has to be towards right. If Fs is to be towards right, my spring is to be compressed, not
Always
elongated.
compressed.
And this we have discussed in class, students. All right. Did you understand why is it compressed?
Yes, sir.
Vignesh, have you understood why is it compressed now?
Yes, sir.
Gayatri, Bhaskar, Navneet, Sofyan.
Understood, sir. Understood.
Yes, sir.
All right. So how will I find the force tension in the spring? That is Fs. Fs is equal to NH. N is equal to 4mg by 5.
Energy by
So NH would be, if this is 37, this is 37. N sine 37 is NH. So N is how much? 4 mg by 5. Sine 37 is 3 by 5, which is equal to 12 mg by 25. That's the compression, that's the force or tension in the spring. Is this force with which the spring is pushing the capital M towards right? Because normal reaction is pushing it towards left, spring force is pushing it towards right, keeping the masses in equilibrium, keeping the capital M in equilibrium. Now let us change this question a bit. Instead of having a spring here, I'll have the spring there. Now tell me whether the spring will get elongated or compressed.
Compressor.
Compress.
Here also compressed, there also compressed. There's no difference.
One compress, one extends.
There's only one spring.
Compressor, always compress it, this one.
Gayatri, what do you think?
Compressor.
Vignesh?
I'm also thinking it would be compressed also only.
Okay. Bhaskar?
I will compress it.
I'll draw the FBD of the capital M. Normal reaction is this way. It will have two components, NH and V. This NH is towards left. For that to be counterbalanced, my spring force is supposed to be towards right. Because it's in equilibrium, static equilibrium. If my NH is towards left, spring force is supposed to be towards right or left.
Left.
अरे स्प्रिंग फोर्स
Right
कैसे
side.
लेफ्ट होगा? हाँ,
Nice,
No, no,
right.
sir. Right.
Right, right side.
see, NH is towards left, that is to be counterbalanced, cancelled, so that other vector should be opposite directly directed, no?
Yes, sir.
So NH is towards left, TS should be towards left or right?
Right, sir.
Right. It should be towards right. If the spring force is towards right, this spring is to be elongated or compressed.
Elongated.
So it's elongated. Why do you say compressed then? That is why go with FBD. Any damn problem in Newton's laws, if you draw the FBD correctly, analyze the FBD correctly, you're done. All right, so it's extended. All right, now let's look at another problem. Acha, how much is the force now? Can you tell me what is the tension in the string? Calculate and tell me what is the tension in the spring. I'll give you 1 minute or 2 minutes. Take whatever time you want, but I want the tension in the spring. Tell me tension in the spring, students. This is 2.5 kg. That's okay. See, if you are wrong, that's okay, but make an attempt. Use pen and paper. Put your pen on paper. Pen your thoughts. All right. Your thoughts will take shape. It's okay if you're wrong, I'm telling you. We are still in the beginning. That's okay. We don't have an exam in 2025. We have exam in 2026, but for which we have to prepare every day, make our brain work every day, train our thought process every day.
Sir, G by 2.5.
Sorry,
G by 2.5.
G by 2.5.
Yes, sir.
What is it like? What did you do?
2.5 kg by 33. Mm,
I really don't understand what you're saying. Navneet, I mean, I don't know whether you're not able to convey or are you doing something wrong. I'm not getting it, but you will.
Wrong, sir,
You're
wrong.
you're, you're getting absurd answers.
Answer is wrong.
Still into old problems only. See, same. It's same as just now what we have done. It's same. No change. See, let me do the previous problem again. Otherwise, I draw the normal reaction on this one. It has got NH component, NB component. NH is counterbalanced by force in the spring. If I just find out NH, I'm done. But what is NH? N
G by
sine
2, sir.
37.
Answer G by 2.
No, it's wrong. So N is this angle is 37. N sine 37 is NH. So how much is N now? N I'll get it from the upper block. N mg cos theta. Mg into 4 by 5 is my N. So 4 mg by 5 into sine 37, which is 3 by 5, which is 12 mg by 5, is what I got as normal reaction.
12 mg by 25.
25, 12 mg by 25. So that is what I got in the last case. What is in this case, I'm asking you. Do the same procedure now. How do you do it now? You have to just do the same procedure for this one. Either you have not understood this or I could not convey this to you. If you want me to repeat this clearly, I'll do it again. But this one is what you have to do. I mean, you have to tell me the answer to this. I will not tell you the answer to this one.
So
Yes, Gayatri, you're saying something?
No, sir.
Okay. Yeah, Vignesh,
So is it same for the second one also answer? 12G by
how
30.
how is it same? Why is it same? Did you draw the FBD and tell me, are you telling me the answer after drawing the FBD?
Yeah, sir, I think I did anywhere wrong. Let me check. 1 minute,
Yes,
sir.
it is. Your answer is right. I'm just asking the reason.
So are you sure is it the answer is correct?
Answer is correct. Answer is same. 12 mg by 25 in both the cases. Here it's compression. Here is extension. But the
Which
tension is same.
normal and tension force. And at the mass 2.5 and 37 degrees and sine 37 mgb and 5 and into 3 by 5 and equal to 12 mg by 25. So I got answer 12 mg by 25.
That's right.
Same ఇలానే వచ్చింది సో ఐ మీన్ ఈ what is called
Wedge.
వెజ్ ఆ వెజ్ కి ఎలా వేస్తానో సేమ్ అలానే వచ్చింది సార్ దీనికి కూడా.
Ante, ante. Same thing. That's right. But just be confident and I'm asking you to put it on paper. Answer వచ్చేస్తుంది. And you are right, Vignesh. But all I was asking you is ఎవ్రీడి డ్రా చేసి చెప్పావా, రఫ్ గా చెప్పేసావా, లైక్ ఫ్లూక్ గా చెప్పేసావా?
లేదు సార్, మీరు ఎలా చెప్పారో ఇంతకుముందు చేసినప్పుడు నాకు 10 mg/25 వచ్చింది.
ఓకే.
నేను ఐ థింక్ అప్పుడు సైన్ వాల్యూ 3/5 కాకుండా 2/5 తీసుకున్నా. అందుకే మళ్ళీ రాంగ్ ఇక్కడ అయిందా అక్కడ అయిందా, మళ్ళీ ఇక్కడ మీరు సైన్ 37 చెప్తే 3/5 చెప్పారు, నేను ఎక్కడ రాంగ్ చేసుకున్నాను చూసా ఆన్సర్ అప్పుడు కరెక్ట్ వచ్చింది.
ఓకే. సో ఇట్స్ ద సేమ్, యు గెట్ ద సేమ్ ఫోర్స్.
Yes.
Right. Now there's one more question. This is moving with an acceleration of 2.5 meters per second square. Force applied is 10 Newton. Mass is 2 kg. And this is 3 kg. And this is 2 meters per second square. Sorry, not 2.5. All right. Given an acceleration of this one, I have to find the acceleration of this particle, 3 kg. Acceleration కావాలంటే నాకు ఫోర్స్ కావాలి. ఫోర్స్ వచ్చేస్తే యాక్సిలరేషన్ వచ్చేస్తుంది. F/m is force, acceleration. But now force కావాలంటే tension in the spring కావాలి, because tension is the only force acting on this particle, this 3 kg block. So if I get tension, I'm done. But how will I get the tension? From this block. The question is, given an acceleration of this as 2 meters per second square and force applied on this is 10 Newton, find the acceleration of 3 kg block. ఇక్కడ నుంచి టెన్షన్ వస్తుంది. ఆ టెన్షన్ ఇక్కడ అప్లై చేస్తే T is equal to 3 into A చేస్తే acceleration of 3 వచ్చేస్తుంది. But how do I find tension is the question. చూడండి, I need,
సార్
yeah,
అక్కడ 2m m-2 అది యాక్సలేషనా సార్?
2 meters per second square is the acceleration given. 2 kg mass, force is 10 kg, 10 Newton applied. చూడండి, F minus T is equal to 2 into A, right? Or A1 అనుకుంటే, this is A1 అనుకుంటే, this is A2 అనుకుంటే F minus T is equal to 2 into A1. So T is equal
10,
to
sir.
tension ఎంత
Minus
వస్తుంది? Tension 6 Newton వస్తుంది కదా?
Yeah.
Is it correct?
Yes, sir.
Tension is
Yeah,
6
sir.
Newton and tension that 6 Newton is towards left. అంటే spring is elongated. ఒకవేళ స్ప్రింగ్ కంప్రెస్డ్ ఉంటే చూడండి, let us say spring is not compressed or elongated at all. So what is the tension, what is the acceleration of the particle? 10/2, 5 ఉండాలి. But acceleration is less than 5. అంటే I've got some opposing force here. That opposing force is tension. So F minus T is equal to mass into acceleration. So tension is 6 Newton. 6 Newton pulling ఉంది. That means my spring is elongated. If this is elongated, this 3 Newton, this 3 kg block is being pulled towards right with a force of 6 Newton. So 6 is equal to 3 into A2. So A2 is equal to 2 meters per second square. You all understand what I did? Students, there is one more question, good question coming up, but if you all cooperate with me and understanding this question, I can go ahead with another question. So I mean, there is one good question coming up.
Yes, sir. This is clear.
All right, is clear? All right, good. See, all I did was F minus T, F plus T ఎందుకు రాలేదు నేను? Because T లేకుంటే my acceleration would have been 5. Given is less than 5. That means F is being reduced. That means there is some opposing force here. That means tension is towards left, not towards right. See, spring can give me both push and pull, but here it's pulling. How can I say that? Because my acceleration is supposed to be 5 if there were no tension, but it is less than 5. That means tension is towards left. That means string is, this is elongated. If this is elongated, this 3 will accelerate towards right. That's what I can say now. I can conclude it after I get T. T is 6 Newton and 6 Newton is equal to 3 into A2. A2 is 2 meters per second square, but towards right. అదే ఇది 12 ఇస్తే, యాక్సెషన్ ఇస్ 12 ఇస్తే అప్పుడు ఏం చేస్తాను? F plus T is equal to 24. T is equal to 14. 14 by 3 is my 14 is equal to 3 into A2, which is acceleration is 14 by 3 towards left. Do you see the difference, students? ఇది 12
Yes,
చేస్తే
sir.
నేను T ని రివర్స్ చేస్తాను. 12 చేస్తే ఎందుకు? 10/2 is 5 meters per second square, but ఇది 12 meters per second square తో మూవ్ అవుతుంది. అంటే there is some force which is supporting F for it to accelerate. అందుకే 5 కంటే ఎక్కువ వచ్చింది acceleration. So I'll write as F plus T is equal to 24, mass into acceleration. Then I'll get T, I'll use T here. But over here, T is pushing towards left because string is compressed now. T plus T వచ్చిందంటే it's compressed. So T will be pushing it towards left. So acceleration of this particle 3 will be towards left. All right.
సార్
Yes.
ఇంకా మాకు మ్యాథ్స్ క్లాస్ లేదా సార్ ఈరోజు?
Maths class. Oh, we'll get to know in 2 minutes. There is some network issues, over there. So we'll get to know in 2 minutes. If there's no maths class, I'll continue. Sorry?
పర్లేదు సార్, మీరు చెప్తారంటే ఓకే. అలాగే మ్యాథ్స్ క్లాస్ ఏమైనా ఉందా, లేకపోతే కంటిన్యూ చేస్తారా?
I'm waiting for the confirmation. All right.
ఓకే సార్.
So if there is class, I'll just leave you with a question. If there is no class, I'll continue with 2 more questions.
Continue చేయండి సార్.
Yeah, okay.
కంటిన్యూ చేయండి సార్.
Because of this heavy rain, there's network issues. No? So there's some force acting here, 13 Newton force. The mass. All right, you don't have a maths class now. All right, we'll continue for 2 more problems and then we'll leave. So Manchi problem only, we'll discuss the problem and then we'll leave. All right, you can leave early now and you can work on something. Be it math homework, chemistry homework, or physics
చెప్పండి
homework.
సార్.
Sorry.
4-5 ప్రాబ్లం చెప్పండి.
Okay. So this is 5 kg block. This is 2 kg block. This 30 Newton is applied. I have to find the accelerations of the blocks. This pulley is massless. Massless antenne, what happens is this will be F by 2 and F by 2. Okay, the string has got same tension along the string. So E force will be equal T and T. So 2T is equal to 30. So T is equal to 15 Newton. All right. So I got the tension in the string now. If I draw the FBD of the particles, 5 kg block the 5G downwards, normal reaction upwards, tension is 15 Newton upwards. 2 kg block, 2G downwards, normal reaction upwards,
Tension is 15.
15 Newton upwards. All right.
Yes, sir.
Now look at this. This is 50. G 10 anukundam for convenience. 50 is 20. So what is the normal reaction now? 50 minus 15, which is 35. So normal reaction is 35. Normal reaction ఎంత ఉంది? 20 minus 15, 5.
5.
So this, what is the acceleration of the particles now? They are being counterbalanced. Forces, all the forces are being balanced. Normal reaction is self-adjusting force. Net force ని చూసి normal reaction will self-adjust. 50 minus 15 కాబట్టి 35. అదే ఇది 15 లేదనుకోండి, that time normal reaction is 50. But if this 15 is there, normal reaction will self-adjust to make it 50 minus 15, 35. All right, do you see this point? Normal reaction is self-adjusting. So what is the acceleration of the particles now? Net force is 0. On this is 0, net force on this is 0. So normal reaction, acceleration is 0. ఒకవేళ acceleration కావాలంటే it should get lifted up, right? Acceleration కావాలంటే it should get lifted up. That means normal reaction should become 0. Only then it will get lifted up. అప్పుడు acceleration వస్తుంది. But normal reaction is non-zero. So normal reaction is non-zero అంటే acceleration is 0.
Why Newton?
All right. Now if I make it 60 Newton, what happens? నేను 60 Newton చేస్తాను. 30 Newton కాకుండా 60 చేస్తాను. So what is the tension in the spring? Tension will be 30 and 30.
30
Correct.
Newton.
30.
Correct. Now if that is 30, so what is the normal reaction now? It is 30 అంటే 50 minus 30, it is normal reaction is 20.
20.
So normal reaction is still not 0. So that means the block is not lifted up. Block
Yes,
just lift up
sir.
అయితే normal reaction 0 అయిపోతుంది. So acceleration is 0. But for
0.
this block it is 30 upwards, 20 downwards. So net force is 10. So it will go up with an acceleration, some acceleration A naught, which will be 30 minus 20 is equal to 2 into A naught. So A naught is equal to 5 meters per 5 meters per second square. All right. So one block will move, the other block will not move. So this block will remain at rest. This block will move like this. And this pulley will go up, this block will move. Before, the pulley doesn't move, these blocks both the blocks will remain on ground. But if it makes it 60, this will become this will be at rest, but this will start moving with an acceleration of 5 meters per second square. Now, what if I make it 140?
Tension will be 70 newtons, sir.
Right? That's
70,
right.
70.
Yeah, good.
70, 70.
Okay.
Accord also 70. 70 minus 50,
Sir,
20.
5 kgs mass ki 4 meter second square into, sir.
It
Acceleration.
will accelerate, sir.
Correct. 70 minus 50 is equal to 5 into A.
20.
5.
2 kgs mass ki
Yes, sir.
25 meter second square into, sir.
Yes. Yes, that's the initial acceleration, right? That's right. That's it. Good. Okay, now let's go for a better problem. I've got a capital mass M. I mean, capital M has one mass. There are two masses here, 1 kg and 2 kg. This is 1 kg. This is 2 kg. The question is, find M, capital M, such that 1 kg moves with constant velocity. Alright, this is the first time we are dealing with such a question. ఇప్పుడు వరకు మనం కన్స్టెంట్ ఈక్వేషన్ లో యాక్సలరేషన్స్ కనుక్కున్నాము, వెలాసిటీస్ కనుక్కున్నాము, కన్స్టెంట్ డైరెక్షన్ కనుక్కున్నాము. But here he says this should move with constant velocity. That means its acceleration should be 0. That means net force on that should be 0. You have to find out M such that this 1 kg mass goes down with constant velocity or moves with constant velocity, V0. That we are not bothered. What is the velocity? We are not bothered. But it should move with constant velocity. That means acceleration should be 0. If acceleration is 0, what is the tension in the string? Sorry. So I'll draw the FBD of 1 kg block. T 1G. T minus 1G is equal to 0. So T is equal to 10 Newton. Do you all agree with this? 10 Newton.
Yes, sir.
Now, if this is 10 Newton, what is the tension over here? 10 plus 10, 20, because this pulley is massless. Pulleys are massless unless otherwise mentioned, they are massless. All right, so tension over here is 20 Newton. If that is 20, what is the acceleration of this particle? 20 by m. Is it okay?
Yes, sir.
Okay, now look at this. If this acceleration is a naught, I have to. What is the acceleration of this particle? A2. I'll redo this problem. Don't worry. Just understand what I'm doing. I'll redo the problem again, but you understand this problem. Acceleration of this is a naught. I have to find the acceleration of this 2 kg particle. How will I find it? I'll use that pulley equation. Acceleration of this point is 0. Acceleration of this point is required. Acceleration of this point is a naught downward. So I'll write a naught is equal to question mark plus 0 by 2. You all agree with this?
Question mark equals to 2.
Yes.
A
2
naught
a naught.
equals to 2.
So question mark is 2 a naught. That means acceleration of this is 40 by m.
M.
Right. Now I'll draw the FBD for 2 kg block. 2 kg block की FBD draw just tension 10 Newton. This is 2 kg, 2g. Acceleration is 40 by m. Now, what will be the equation, Newton's equation for this one? I've drawn FBD and MAD both. So 2g minus 10 is equal to 2 times of 40 by m. So I'll have 10 is equal to 2 times of 40 by m.
Yeah.
2 ones, 2 5s, 5 ones, 5 8s. M is equal to 8 kg.
8
kg.
Do you see what I've done? Do you all understand what I've done?
Yes, sir.
Yes, sir. Understood.
All right, see, this was moving with constant velocity. That means acceleration of this particle was zero. If this acceleration is zero, this acceleration was question, if we say it's question mark, and this is a naught is equal to question mark plus 0 by 2. That means this is moving as if this is fixed. V naught 0 అనుకుంటే is fixed. ఇలా move అవుతుంది particle. So push pull method తో చేస్తే if this a naught moves by x, fully moves on by x, string stack is by x and x, this is 2x. If v naught is 0, he said constant velocity, so it could be at rest also. All right, but we have done it using pulley method. Pulley method చేస్తే ఏమొచ్చింది నాకు క్వశ్చన్ మార్క్ వాస్ 2 into a naught.
Sir,
Sir,
Arun sir.
yeah. Hello, sir. Any issues? Hey, Ganesh. Enjoy yourself. बात कर रहा हूँ ठीक क्या बोलना है से बात दिनेश 4 2 मिनट में आ रहा बारिश गिर रहा था तुम्हारा Maths class में है आज.
Students, you don't have math class because of bad weather. Sorry for that. All right. And after this problem, we'll just wind up. There is a power cut here as well. I tried to reconnect, but there's a network issue here as well. But we can continue. But we'll just wind up after this problem, whatever you are comfortable with. But don't waste time, whatever you're now. Right? Don't waste your time and utilize this time, whatever time you're now getting. All right. So that's it. So here, acceleration of this is twice of this acceleration, 2a naught. Now I write the FBD of this block, 2 kg block. 2g downwards, 10 Newton upwards.
Class is end.
All right, students, let's wind up here. All right, you can continue with your studies. You don't have a class now. You please continue with whatever you want to study or relax for some time and then get back to studies. All right, maths. Give importance to all these three subjects, maths, physics, and chemistry. Any subjects importance ఇవ్వండి. Don't just focus on physics or chemistry or maths. మీ ర్యాంక్ కోసం all three subjects are important. Right? All right. Thank you all students. See you tomorrow morning. Bye everyone.
Okay, sir. Bye, sir.
Bye, sir.
Bye, sir.
Bye. Bye.